We are going to the next panel discussion. In this case, it's panel 4. It will be a mix of the works being produced already by both Cluster D and Cluster E. And I would like to invite Henk Samson as a moderator of this session and all the panelists participating. And in the meanwhile, we're going to see a video of the Cluster D activities.
My name is Henk Samson. I work as a senior program manager at FP3-IAM4Rail Netherlands and represent FP3 in the participation of Europe's rail joint undertaking, both in general and in specific ongoing projects. In the IAM4Rail project, I'm a work package leader and also co-lead one of the clusters. Within this cluster, the focus is on measuring and monitoring rail infrastructure to understand its behavior and to use the resulting information for defining short-term maintenance interventions and long-term asset management. The cluster comprises 4 work packages in total. The first introduces new technologies and combines existing ones to gain new insights by merging various sources. The push and pull approach we take involves exploring the potential of the new technologies while addressing urgent real-life infrastructure issues that require better understanding to support daily maintenance. The next 2 work packages focus on specific assets, one on the rail track itself and the other on civil assets. The fourth focuses on long-term asset management and leverages for this purpose results from the other work packages where possible. 2 of the key developments nearing early implementations are what we call the reality model and the monitoring network for geological risks. The reality model is a digital representation of the actual situation in the field projected against the original drawings or design information for future work. This allows us to check if the real-world conditions match the design assumptions. We use LiDAR systems, 360-degree point clouds, track scan data, and a ground-penetrating radar to detect objects below the surface. This helps planning of the placement of balises and ensuring that the design matches the real conditions. For example, by highlighting areas where balises should not be placed due to potential interference with other assets, we can prevent unexpected issues during the execution. The monitoring network for geological risks includes a weather station and a network of wireless clinometers. These sensors enable on-site and real-time data collection of embankment movements around the rail infrastructure, providing inclination control. The data is visualized in a data platform enabling the combination of the various data sources. Based on this representation, experts can better understand ground behavior and prevent incidents. Future developments in this cluster focus on new technologies. We employ a multi-scale approach involving satellites, drones, wayside systems, ground-penetrating radar, testing fiber optics for trackside vibrations and seismic activity, and onboard measurements, for example with a laser Doppler vibrometer. In general, we believe that by consistently collaborating with researchers and end users over an extended period, we can advance new developments to high technology net readiness levels, making them ready for market uptake and deployment, thus improving the reliability of the rail infrastructure. To involve researchers from outside the project, we are considering the possibility of making our data available for further research purposes.
So for this panel discussion, which is called future trends in railway infrastructure management participation. The moderator, as I mentioned, will be Henk Samson from Structon. You have the floor.
Okay, yeah, thank you. Is it on? Yeah. Thank you for giving me the floor and to host this panel discussion. We are actually discussing two clusters. So you just saw the introduction of Cluster D, but it is also part of Cluster E, which is about the digital twin. I am supported here by Fulvia Berti, but also by Jurgen Groos from DLR, Naomi Gemnes, I am always pronouncing names from below the Alps, and Thomas Guckler as outside the project, but from SBB, and giving an external view on what you see here today. We start off the panel discussion by I will give each one of you the floor to give a short statement about your own activity or actually the work package you stand for. So I would go for Fulvia.
Yeah.
The floor is yours, and I need to do something here. How do it? Oh.
Maybe the X. No. Oh, okay, it's going. Okay. Yeah. So good morning, everyone. I'm Fulvia Berti. Thanks for having me. It's the first time here presenting at the midterm for me, so it's everything new, and I'm learning so much from everyone. I'm from Italfer, Italy, and I'm here representing Cluster E, as Hank said. So we are both together, E and D, where we are focusing on digital twin in railway infrastructure. So let's start saying that on the railway, the assets are the main elements that we have to manage and, of course, detect during time, in real time, such as telecommunication, trains, or all the other assets that are crucial for the safety and operational maintenance. For doing that, we use advantageous technologies such as you can see, airborne system, drones that detect all the data through a specific line of the railway. And then after collecting them, they can be used for creating a 3D model. All these data are, of course, managed in a digital system where we can manage them and monitor them in real time to always be updated on the status of the railway. Then, as I said, it's important to create a 3D model to collect and put all the elements and the data for each asset on the 3D, and also with the technology of the VR, so virtual reality, also being able to create an immersive model that we can navigate in. Of course, going physically on the station, in this particular station, Malaga Maria Zambrano, but in Spain, but also directly from the office or wherever we want using a VR. This creates an asset inventory using technologies and helps us also to create a collaborative system between all the stakeholders and the team member. Of course, at the end, we are working in our cluster on training algorithms for computer vision to, in this particular case, to detect the dirtiness, the wear, and degradation of the station. What is important to say is that we don't have to physically go on the station and make it dirty, but we can use synthetic photos and data directly from the 3D model that can help us training the algorithms. And using cameras, thermal cameras inside the station, we are able to detect and easily understand where is the need of an immediate action, of cleaning maybe. And this kind of technology, of course, can be used also for other use cases that are important for all the safety and maintenance in the railway infrastructure.
Okay, thank you. Nice opening statement. So we keep this all in mind. We come back to this. I will hand over to Naomi. Tell us a little bit about the activities that you do in our cluster.
Okay, so firstly, thank you so much to Adif and the organizing team for inviting me here today, and also for him for leading this panel. And so I would like to start focusing a little bit about what Cemosa does and how we land in infrastructure asset management. So Cemosa is a Spanish engineering consultancy company in the field of infrastructures. So we deal with railway infrastructure, but not only. We also take care of roads, airport, ports, and other kind of infrastructure, such as buildings, power plants, water infrastructure. And we cover the whole life cycle of the infrastructure. So our mission is to contribute to more sustainable, more resilient, and better managed infrastructure in general. And we do that by putting a lot of emphasis on research and innovation, and also on digital technologies. We are a founding member of Eurosrail, and we are associate member of Shift2Rail. And one of our key features in this partnership is precisely the fact that we are transversal. We deal not only with railway infrastructure, but with other kind of infrastructure. And in there we find synergies and similarities, and we can apply technologies that we find in one sector in another sector. So within IAM4Rail, we work in Cluster D. We develop artificial intelligence technologies for civil infrastructure asset management. In particular, we are working together with Adif in system oriented for bridges and for earthworks. For bridges, we are working on machine learning techniques for prediction of the condition of bridges. This is a system oriented toward tactical planning, and it allows us first to detect anomaly, and second, we can identify damage, detect damage at the location of those damage. And as I said, we're working in this together with Adif, and we are applying it in a bridge in a high-speed line in Madrid-Valencia line. We are also working on deep learning technologies for developing an early warning system for earthworks, and the goal is to detect landslides. And in this case, it is oriented to operational or emergency management. And again, we are able to detect anomalies, and then we are also setting some alarms. In all this development, we are integrating all this development in our GIS BIM-based digital twin asset management platform, which is Zenbox, that was shown over there and was also included in the preliminary video. So in this platform, we are able to visualize what we do and the methods and the technologies that we do, and it is oriented for decision making.
Okay, thank you. I would like to hand over to Jan, because you work also in this cluster, and I asked you to say something about more with the background of all the data that we collect and the vision, but that might be a little bit similar to what we saw before. But please go ahead.
Yes, thank you. Yeah, so I'm from the German Aerospace Center, and I know if you maybe show the next slide. Yeah, so we are involved in IAM4Rail Work Package 10 and 11, and we have talked a lot today about that we need to bring together data from different sources, and I think we have an agreement upon that. And we as a German applied sciences research institution, engineering research institution, we are working, let's say, on most of these technology components along the entire track, so from the left, so from the embedded sensors, wayside, and on vehicles, across this topic about the data management, getting data together. We are part of the European Rail Data Space Initiative, stemming out of Motional, so flagship area 1, and also then about the analytics. And me personally, with my working group, we are involved in IAM4Rail, especially on the right side of this figure, so to getting information out of the data. But of course, we need to combine the data, and therefore we work together with our other DLR colleagues, active also in the other flagship programs. And my personal vision would be that we utilize these tools for our own work. So from an egoistic perspective, we have heard it this morning, 90% of the time are consumed to get data prepared to do the real work. And we want to reduce this significantly because then we will make larger and faster progress. And for that reason, our idea is to have a demonstration, an integrated demonstrator within the Europe's Rail context, and we are very happy to work together in IAM4Rail with the partners, especially the VP10, VP11 partners, to have a pilot site where we can do this specifically. And this is, in this case, a pilot site in the Netherlands where we really combine productive inspection train data. We have, you see on the lower left side, this experimental vehicle, Leonardo by Structon, which mimics, on the one hand, let's say an in-service vehicle with the sensors, but also a modern multi-sensor inspection vehicle. We have the production wayside monitoring systems and weather information and all the other information we have to bring together and to really build up across the next years to get some kind of demonstration of this entire workflow with the technical enablers like a data space, like a digital representation, then enhanced towards a digital twin when you bring simulation technologies in as well. Last remark, because we have talked a lot also about the lack of efforts or the lack of resources to do so. And two things, if you think about future trends, would be more open. Because if the railway sector tries to do everything alone in a closed shop, it will be a hard shop. And all others might be, a lot of others might be faster than we. And we have seen, for example, ROS for railways. So ROS is a robot operating system. It's an open source software, mainly driven by industrial developments, by the way. And we need open data, because if we want to train machine learning and everybody starts from the scratch, beginning, getting his own data together, it will take years. So I think these are two main trends for the future, how we can make it more open to unleash also the resources, maybe also outside the railway sector, to get other technologies in, and also maybe to get others interested to solve the problems which might be challenges within the railway sector. Thank you.
Yeah, I would like to hand over to Thomas. You are, not completely outside Europe. You're not completely outside Europe's rail, but you're not part of this project. So we invited you also with a view from SBB to be more like the devil's advocate. First of all, to say, can you use what you see here? What are you doing yourself? But for the rest of the discussion, be our devil's advocate. Go ahead.
Thank you, Henk. I try my best to be devil's advocate coming from a neutral country. But I can give a neutral advice and maybe link something to what we do. You're right, we are not participating, unfortunately, in this wave, maybe in the next wave. It depends also on the consortia. We are involved in the system pillar. My colleague here just presented something about HERT, the Harmonistic European Rail Diagnostics, which is very important for us. And we're involved in Flagship Area 2 for the automated train operation and also in DAC, in the Flagship Area 5. And I have a short summary. I will just fly over it to not take a lot of time. We can go deep inside if there are some questions later, maybe for the last presentations we have, the robotics. There was a question, what kind of robots should we have or what we want to have? And I think this approach of modularity is very good, especially what we see with the SNCF demonstrator here, which you can equip and enhance to your needs. But we also need fit-for-purpose robots. For example, Gotthard Base Tunnel, over 50-kilometer long tunnel in Switzerland connecting North Europe to South Europe, especially Italy. And whenever we maintain there something, we have to shut down the line totally, which means that we do not have traffic. So we are looking for robots that help us to maintain such kind of tunnels. For example, a drainage robot, which fully autonomous can clean the drainage pipes. Or also in a hazardous situation where we have a landslide, for example, to have a remote electric shovel that can help us restore the line. Another part which I heard was the human-machine organization. David also mentioned it for Industry 5.0. We are developing more tools, digital tools, and we need to have the users to use them. Usually they're not data experts, they're not IT experts, but they should use it to get the most value out of it, so we can have this value of user decision support. Then data, of course, it's important to gather it, also to protect it. The level of openness is important here. I think as an integrated railway, we have a rolling stock, infrastructure, cargo, everything together. We have a lot of data, we can use it. And we also need this data from sometimes critical infrastructures to train our models. So train them, also validate them, but we cannot make them available. So at the end, what's important to know what kind of part of the simulations, of the models, of the data we can share, and what kind do we need to use to make the best tools for our operations. And then we have the implementation. I already mentioned it with the users at the end. I think it's very important to have tailor-made business processes for every tool that comes up, for every model that we're using for the simulation. And we also heard that to get the value to the stakeholder. We have short, middle, and long-term planning, and with all the developments I have with these models, the more information we get for predictive maintenance, for example, this is going to increase the short-term planning disruption. If I know better about my rolling stock, I can use it more flexible. But of course, more flexible means also to have it more flexible in the maintenance, and by that. We need simplicity, robustness in those models, give us the information. We have these tailor-made processes that help us for the maintenance, and also think that we have to integrate all the data that we have from the railway system, even if it's from onboard or trackside, to combine it together.
Okay, thank you. Yeah, I would like to start a discussion. And by the way, I will open the floor actually to all the public, so feel free to interrupt as well. Listening to what we have seen so far, and also in all the previous discussions, we were asked to present here 2 clusters, and then we lift up to a very abstract level. So if you're not careful, we will end up in the same discussions as before. So I would like to address a couple of things in these discussions. One is, because we are so abstract, that we move a little bit away from the practical applications. So I would discuss also the practical applications that are actually hidden there. Naomi already, and also the video explains a few of these practical applications. So that's one issue that I would like to address. Another thing is, I would like to address the availability of data and the challenges on that. We have discussed this on a very abstract level, but I will go back to that later. But there are some other elements that I would like to include there as well. And last but not least, and Thomas already alluded to that, that is, it looks as if everything is honky-dory and that we have a lot of technology, but then it needs to be implemented. So what are the challenges in the organization? So these are the 3 topics that I would like to address. To start off with the first one, the applications. You might repeat yourself a little bit, Naomi, but tell a little bit about the applications, and I will ask also Fulvia and perhaps also Jörn, because you're also involved in the work packages, so you can address also a few practical issues that applications that we work on. Floor's yours, Naomi. Very short.
Yeah, so regarding the application, we have 2 very concrete applications about machine learning. The first one is about machine learning technique for the prediction of the condition assessment of bridges. In this case, we base on IoT, on an IoT monitoring system. We analyze automatically all the data using operational model analysis. We remove the effect of weather condition. At the same time, we develop a finite element modeling, which we calibrate using the IoT data. And with that, we are able to detect anomalies. Once we detect anomalies, we detect an anomalous behavior using engineering knowledge. We decide which part of the bridge we're going to make a more detailed model, and to that model we apply machine learning techniques together with the knowledge of the characteristics of the mechanical characteristics of the bridge, and then we are able to concretely detect damage and locate the damage. And so that's a big achievement.
Yeah. Okay. So a really practical use of all the technologies that we talk about in a very abstract level. Yeah. I'm going to jump a little bit to Jörn. Jörn, perhaps you're surprised by this question, but could you say something about, we work for a long time together, the Alliance platform?
Yeah, so if you put one main application in the middle, it would be the monitoring of the turnout and switches.
Mm-hmm.
And we started in FP3-IAM4Rail already a long time ago with a focus on the wayside monitoring systems for switches. And now if we look towards this holistic approach, then to combine the data sources. So what is the inspection trains measuring at the switches? What are maybe in-service trains measuring with, for example, accelerators we have discussed today? And to bring together this with weather conditions, but also with other wayside measurements. For example, if you measure a current at a switch, then it might be interesting to measure the voltage at all, but this was not done yet. So, so one thing is that we are not doing revolution every project. We want to build upon what we had before. And now the main purpose is on working to bring together these data sources. And then we talk about the challenges about bringing together the data. In far most cases today, you have a single use case solution. So you have to find the right people knowing what is the available data. Then you have to get an agreement that this data can be used, even for development or research. And then you have to get this data out of its silo, bring it to the other person who needs it in some way. If it's maybe, let's be 100 gigabyte of data, you might crash a diff SharePoint, for example. And so these are the practical challenges. And then you have to understand what you get. These 90% of the time is to get the data, be ready to work with it. And this is the main challenge. And then we are talking about the data models, and we are talking about the CDM, I think, since the early beginnings of FP3-IAM4Rail. So we see that this is a quite complex topic to be solved. And this, I think, is the main challenge, because when we see where we lose the effort, where we lose the time, it is not with the real challenges, technologies-wise speaking, in my personal opinion. We are losing a lot of time in things which could be technology be solved, but we need some kind of agreements. We have talked today already about interfaces, about common interfaces, about harmonized interfaces, and this is, I think, one of the main game changer we have to fulfill. Yeah.
Okay. Last, about applications. Can you mention, Fulvia, some applications that you use, are using the digital twin for?
Yeah. So the digital twin, of course, is as you all know, digital replica of the physical asset. In our specific company, we are working on, as similar to Samosa, working on creating a 3D model and then integrated the 3D model with the IoT sensors that can give us a response of how the structure is working, and of course creating alarms in case of parameters changes, and be able to immediate respond to the issues. As the same thing we are doing, of course, in a different use case in our cluster, because as I said, we train algorithms for detection of dirtiness and wear. Mm-hmm. So using cameras inside the station. And those cameras, of course, are always useful and be helpful as IoT sensors inside the station, not only for the specific use case of degradation and dirtiness, but also can be implemented for other use cases. But of course, the main, as all the panelists also said, the main expertise and main challenge is, of course, collecting all the data and make them not put in a silos. So only some stakeholders can use and visualize them, but create a real digital system that allows all the stakeholders to achieve the data.
Okay. I just add to myself a little bit from what we're doing in our own cluster. I know that Said is here. They are also looking at the vegetation, so overgrowing the track, which can be really a practical solution that we need, but also invasive vegetation can be detected. And one throw-in comment about the robot. Actually, maintaining a track is linear farming because all the vegetation needs to be maintained. And we are not allowed to use chemicals, so why not having a robot? So we perhaps should look a little bit more to agriculture and to have a robot in the future going along the track. But it was just a throw-in thing. You mentioned a few times things about the data, and there are some challenges about the data. We discussed this many times before. I would like to have a slightly different take on it, and that is, what are the real challenges? Because is all the data available? So we can also fight a little bit about who owns the data. But quite often, and I think you alluded to this already, Fulvia, not all the data is available. So also when you do maintenance, not all the maintenance actions are really recorded properly. So you run into organizational issues. Thomas, could you say something? I know you're from Switzerland. They are very precise and accurate, but I'm challenging you. How accurate is everything within SBB?
Yeah, it's not always as accurate as you think as a watch manufacturer that we are. But of course, I think this is the normal process when we go towards more digitalization. For example, we have a database for all the fixed installed assets that we have. And sometimes they are not really there where they should to be. So every time when we make an inspection, we have to do corrections. So that by that we have to clean up all the data that we have. And on the other hand, we also had, and we already heard that, different silos where all this information is gathered. So we have a very big program also inside of SBB to have like one data lake with an ontology, with a syntax where we can exchange the data. Regarding privacy or other policies, as I said, we're integrated railway, so we have very short ways in between our different divisions and stakeholders. So this is actually not a real kind of a problem. The big problem starts when we would like to share the data with externals or when we want to get data to use. For example, crowd management at the railway stations. We had a project planned to better understand where the passengers are walking, going to help them to get to the trains. But of course, this was a privacy issue, so we were not able to do that.
Yeah. Yeah, so this is indeed two things. That one is the data really available, because sometimes it is not recorded, and sometimes you run indeed into other issues. Fulvia, from your side, because you're also from the Italian Railways, you're also a data collector, but yeah, in theory it is really easy. In a few words, you say we need to have simple one data lake, but how simple is that to get that data lake?
Of course, it's not simple at all, because sometimes it happens that other companies that detains data, of course, don't want to share them, or maybe you lost some data from the sensors during time. So of course, it's really difficult. We are trying to achieve and to make progresses inside our company, to trying to collect all the data and make our own platform where we can be more precise as possible, of course, to achieve our goal, that is to monitor and create a safer and more efficiency railway.
Okay. To continue I was coming back to you anyway, but anyway, go ahead, Johan.
Yeah, maybe I have one or two thoughts about that. One thing is, we talked also about data centralization and where it would take place. Mm-hmm. And I think it will take place there where we need to centralize data. So this will depend on the application you have, on the use case you have, and then there will be an entity, an organization, a user, whatever, a division of a company centralizing the data it needs. And the question is, how to make it easy to centralize the data you need. Yeah? And I'm totally agree that we say, okay, we should not measure data for the sake of data measurement. Yeah, that's right. So not everybody will centralize everything at his point or her point. But I think we need a little bit of different thinking about the data generated in the organizations, in the companies, between partners, because today we often have the situation that data is gathered for a specific, let's say, operational process or company process, and then you have a silo. And afterwards you think about, okay, do we know that this data exists? How does we find out that this data exists? And then how to access it? If we would from the beginning say, okay, every data collected should be fair, so findable, for example, it's one of these 4 letters, fair. So right from the beginning, that every data is findable and reusable by others, even if we today not know if there might be application in the future to use the data. Because then, if we do this as a principle in general for everything, we might develop in 5 years a new application utilizing data we today are not thinking about. And this opportunity of innovation we are lacking at the moment, because everything is quite to a specific use case, to a specific requirements, and then you are losing flexibility and even good ideas to be tested quite easily because you are not able to do so.
I know that in the past, when we started Shift to Rail many years ago, Naomi was saying that sharing data was quite often at each meeting a hot issue, and we basically started each time the discussion new. And I know that, Naomi, you're working as a small entity, and you depend actually on the availability of data, because otherwise you cannot develop anything. But perhaps a few words on this and the progress in the discussion.
Yes, In Shift to Rail and also in Rail, we need to work on other people data. We work for infrastructure manager, and so we need to belong their data. And so having data has not always been easy. And mostly I understand that the data we need to have is about critical infrastructure, so there is always an issue. But on the other hand, that can be easily solved by signing confidentiality agreement, and that's it. But that's not always it's not always easy. And so for doing what we need to do in artificial intelligence, we need data availability and data quality. That's a must. So we need to work towards that. And also regarding what George was mentioning, I think I agree that data are collected for whatever purpose, but then it may be useful for something else. Probably we need to keep on progressing on data governance procedure, taking care of the availability, the usability, the integrity, and the security of data. So I think we are on progress, let's say.
So the quality of the discussion has improved over time.
Yeah, as people is more aware of the situation, and everyone wants to take full potential of the data, so let's make data available.
Jan, from your side as a researcher, because you have also quite a few years experience in this.
Of course, if you want to try something new, you have to face this all the time. You have to bring things together which were not together before. And if you talk about data, I think it's getting more and more a vital thing, because if we are not able to do so, we will lag behind. And what, for example, is in other sectors evolving already is so-called data brokers. And they are just for the sake of bringing together partners who want to share data, to organize how it is solved technically, how does it solved legally, is there any cash flow for, let's say, letting data flow. And maybe this is also one entity missing in our we have already a lot of stakeholders, and so we don't lacking of complex stakeholder structure, but maybe this is one missing. So who might be organizing somehow how we, between all the stakeholders, exchange data in a reliable, safe, secure way.
Okay. Last but not least, coming back a little bit to the challenges of all these technologies, they need to be implemented. I know the joint undertaking wants to see high TRL levels, and that means that they need to be deployed. That needs to be that they actually company-wide they should be installed. And the railway sector is a complicated one. There are many stakeholders involved. So not only for the data sharing, but also for the implementation. Thomas, from your point of view, because you can look at it as one organization, but do you see also challenges across the value chain, the supply chain that needs, when you want to do something, then we need to have all partners on board?
Yeah, maybe I can give two examples. One would be wheelset maintenance for rolling stock operations, and one would be disruption management. I just said that with the implementation of AI and machine learning, we get these models, we have more information about the condition of our assets, and we can more flexible maintain them and have them work longer terms. But we, as railway undertaking, fully integrated, we have 9 workshops in Switzerland. Switzerland is small, but they're spread over all Switzerland, and the maintenance is planned in train rotation. So when the train goes from Geneva in the south up to St. Gallen in the north, and somewhere there it has to be maintained. And having this information puts stress on the maintenance team, because they work in shifts, 24 hours, they're planned long or midterm. And when you have shorter notification that one train needs maintenance earlier, but the other one can roll a little longer, you're just not able to beam it to where it needs to be for the work. So there we have this application, we have the information, but implementation is very difficult. So this is what I meant with business-tailored processes that need to be done, especially as the planning of the maintenance is usually made manually. So they look at the plan, they look at the trains, and they try to arrange them. And if you have to rearrange them, you just do not have a button to rearrange. You have to figure it out. So this is kind of a difficulty to implement this kind of things. So digital transformation is also about culture. So this is one message. And the other topic, disruptive management, I already mentioned it, Gotthard Base Tunnel last summer. We had an incident. One of the wheels of a cargo train broke, destroyed over 7-8 kilometers of track inside of the Gotthard Base Tunnel, over 50-kilometer long tunnel. Now you can say if you have a derailing sensor, you could have prevented that. But if I look over to my herd colleagues, if we have checkpoints that are from Rotterdam down to Genua connected and we have the same syntax, we can see degradation in the data that we're collecting. We may see anomalies, we may see patterns that we're not doing yet. You're right, we need to find the data, but maybe we already have data and find a way to figure out the patterns, use these tools like machine learning and AI, and then have value out of it. And by that, we do not have silos in between on the horizontal line, but in a vertical line, because we need to connect the countries, the railway undertakings, the infrastructure managers, all together to have this data and get the value out of it. And I think we have to work on that kind of implementation with specification and collaboration.
Okay. Yeah, you confirm a little bit what I was expecting, because our own experience is the same. And you actually referred to the planning, so I might know what the status of the asset is, but the logistics and the planning is quite often an issue. In the past, we have worked on it, and I've worked together with Naomi, with Samosa, but also with Fraunhofer. And then mathematically, the planning is not an issue. So you can crack the problem, but then the implementation is still the issue, because the work processes are different in the organizations, and as soon as you get also not only your own organization but different stakeholders, it is really complicated to get that done. Okay, perhaps I'm always talking fast, so I'm a little bit lost on the time, but I don't hear the audience. And yes.
Okay, thank you a lot for your presentation of both clusters. I've seen a lot of application of digital twin for existing assets, like bridges and stations. But I was wondering, what about new assets? Is it possible to provide digital twin in the design so that it born at the beginning of the phase, so that the asset manager, the owner of the asset, can have the digital twin for the first stages? Is it possible that?
Well, if you ask me, I think you're asking the panel, but it would be actually a perfect question, for example, to people from voestalpine. You say they're here. But anyway, perhaps Naomi, you want to say something?
In fact, maybe when we deal about railway in Europe is already built, and so we start with what we have and we do the replica. But if we start another infrastructure, for example, an airport, we start for the planning, the design, and everything. And so the first digital twin is the design, then we are building it and we are matching what we are constructing with the design, and then the building, for example, the airport is evolving and the digital twin is evolving with the infrastructure. So the concept of the digital twin is oriented towards from the planning until the demolition of the infrastructure. So it's already there.
And also, it could be useful also during the planning and the projecting phase that every single engineer working on each phase of the project are able to detect which are the main elements, numbers that could be used for an IoT sensor installed in a specific point of the project. So also, for example, vibration, temperature, but also movements of the structure. is the engineer itself, the projects, the infrastructure, also to be able to manage which are the could be the problem on the structure, and gives alerts and numbers for the IoT sensors.
Okay, I'm looking at the time, so I'm going to round up, and I would like actually to repeat what in the previous panel was being said. And I've emphasized a little bit the practical applications, because we need to have practical applications, because otherwise we can't deploy them and implement them. We need to have high TRL levels. And Unai said before, we need to deliver something for the people outside in the track. They need to know what is going on there. We need to do it for them. We need to do our homework properly so that it is a solid solution. So I won't criticize at all, let's say, the more engineering, the deep engineering that's going on, it's the academic research that needs to be done. But we need to have in mind that we work on the right issues, the topics that really matters, there where the sector has an itch, and not on the exotic exceptions. I would conclude here. In time? Okay.